Yesterday, did some stuff, excuse me, note-wise with variables on both sides of the equation. We've been introduced to that a little bit even during the last unit. Now we're actually getting a little more deeply into it. So now, we're going to be looking on these to add distributing part of what we're doing when there's variables on both sides. What I've done up here is just one of those things. This was kind of pre-video. I'd be like, people would say, I don't get it when you're not here to explain it. I'm like, well, here I am verbally explaining it. It's just not my voice coming to you. Well, now you can get my voice with it if you want. Or if you don't, that's okay too. So what I'm going to do, bring this down a little bit. Writing utensil? Oh, I was going to say, 'cause these are new. So here, anytime I see the parentheses to start, I'm going to distribute. When I'm distributing, what am I doing? Okay, I'm timesing. And I know some of you like to do multiple steps at one time. But the important thing with these is, take your time. Okay, I'm not going to give you like 10 zillion of them. Like half a zillion. And now it starts to look a little bit like yesterday. But here's the issue. When it says like terms to combine, not exactly. Because for them to be like terms, they need to be on the same side of the equals. And these, my equals is kind of like my wall here. My y's are on opposite sides of the wall. So, they're on opposite sides. So I need to do the opposite to move them. And since I like to keep them positive most of the time, I think it's a good idea for us to move the 3y over here to this side. But how do I do that? Okay. So I need to minus 3y on both sides here. So by doing this, that gives me the opportunity to be able to solve this. So once we get those y's together, now what? Okay. I'm going to divide by 2. And we're going to get to the answer. So it's not an incredibly long process, but it is a process where if you go too fast, you mix the sign up, it can really mess with you. Okay. So we'll just kind of keep doing these for a bit and kind of get you on a roll before we start heading towards, and I'll help out with some of the homework problems too, just to kind of get you a kickstart. Let me bump this up a little bit. And just like we did in the first one, so I want to get you on a roll here. Anytime you see the parentheses at the start, we need to do that first. 3 times negative 2 is what? I do 3 times negative 2x. What do I get? Negative 6. Okay. So again, my x's are on opposite sides of my equals. And like I said, I kind of like to look at the equals as a wall. So I got to be sneaky to get from one side to the other. So what do I have to do to move my negative 6x to the other side? Add 6x. Ah. Because you're like, okay, so that cancels out at 3 is my equals. Well, wait a minute. Now I got negative 6 and positive 6. That canceled. And all I got left is 5. Oh. Correct. Here's my issue. All my x's are gone. So now I have one choice left. Is 5 equal 3? No. That's false. And when all my x's disappear, I have one of two options. If they do not equal each other, that's no solution. There is not an x value I could find that would work in this one. But if they would have been equal to each other, yeah, if it would have been like 5 equals 5 or 3 equals 3, that's all real. Okay? Still no solution. They have to be identical to each other. Good question. Okay? And I think we'll see one here in a bit that's going to be an all real. If not, we might make something up as we go. So again, just kind of in review, since they're on the opposite side of the equals, I needed to do the opposite to get my x's together. And then in this case, I didn't have anything I had to do to get my x. Well, great, it all disappeared. And then this one kind of went away because, well, there weren't any x's to deal with, or y's, or any other variables. They all went away. So that's an option sometimes for these. So as we work our way down, ooh, double distributing this time. I got it on both sides. Yeah, I always have to do that first. I have to watch for signs, and I have to remember that we're multiplying when we distribute, and that's what gets rid of the parentheses. Now again, once I get here, I have choices, but the first thing I really want to do is get all my z's together. I always want to get my variables together first. Okay? Add 3z is an option. If any of you happen to minus 4z, that would work too. So again, our goal here is to get my z's out of one side and all to the other side. Good deal. So all my z's are together now in one place. But now I got to work on isolating, or getting that alone. Okay, add the 20. So 36 and 20 is 56. Now I got my z alone on a side, which is what I wanted. What's my last step going to be? 5 by 7. And z is going to be 8. So it is going to take some patience doing these. We're just going to sort of keep rolling here on that same idea. Multiply when we see the parentheses. What do I get when I do negative times negative? I get a positive 6p. And now we're in the same situation again. My equals is my wall. My p's are on opposite sides of it. So what's one way I could get all my p's to one side? Okay, I could add 5p. I'd do an opposite. We'll get the same answer at the end. We absolutely would. Yep, we absolutely would get the same answer. So it's not like if I don't do the correct p the first time and then I'm going to miss it. Not the case. Make sure I don't lose my equal sign. Okay, because now my next goal is to get the 11p by itself. So we're going to add 32. And then p is going to equal 3 because I divide by 11. That's my opposite of multiplying. So it is. It can get to be, it's a little bit longer of a process when we're doing the 1 and 2 step equations. Now we're kind of starting to put all these ideas together and see how those work out. One last one. Oh, double distributed. Of course, that has to be a 1-to-1. All right, so what's the left side of my equation going to look like when I distribute? 3x minus 3, 3x plus 12. The one we're doing right now is just examples. How do I get all my x's together? Okay. But they also cancel here, so it's similar to what we had back in number 2 up above. Are those equal? No. Oops, I'm off the screen. Are those equal? No. So in this case, we have no solution. Now, when some of you start to look at the homework that goes along with this, first thing I know you're going to notice, and that's why I've got some scratch paper I'm going to have available here momentarily, is you're like, dang, Harty, there's not much room here. It's true. But what it also does, it's going to review yesterday's work a little bit. So here's kind of what this is going to allow us to do. We're going to get a little bit of review from yesterday. I'm going to get a little piece of scratch paper here to work with too. If you notice on the problems up at the top, we've got variables on both sides. One thing I'm going to have you skip for right now, someone's may say, why? Yep, I was going to say, let me get some scratch paper out to you guys here. I'll pause. Trying to complete these, if I think of the equals as a wall, and my y's or x's or whatever on opposite sides of that, I've got to keep reminding myself, okay, I want to get all my y's together. Anybody have a preference on which direction we go with the y's on number 2? Okay. So if I minus 7, so I've got 8 equals 11 minus 7 4y. And then it's just right. It's just divide by the 4, and it's going to be 2. I'm with you. So don't let those type of problems drive you crazy or bother you. Okay? I am, for the moment, because we're not going to start this until Monday, going to let you off the hook on 11, because we haven't played the fraction game yet, on how to get rid of those. We will Monday, though, so that'll have us situated to make those a little bit easier, but not yet. You're like, oh crap, Harty, you got story problems on the bottom. Yes, I do. So when we're doing these, even more than solving them, I want you to be able to set them up. So here's the deal. If you translate them into equations, okay, that's all I'll have you do. Because I really want to stress here that we've got to be able to do some of this. So I'm going to do about half of them with you here. So I want to make sure that you got a good basis to do the rest of them. So, I guess, sure, why not? I'll do the odd ones with you here. I think that'll work. Yes. So, okay, let's jump in there. 14. 4 times Freddie's age is 30 less than 5 times his age. How old is Freddie? Okay, so I'm going to use F here. That's going to be Freddie. Makes sense to me. If you want to use X for Freddie, you can. So, okay, because here's what we're doing. 4 times Freddie's age, 4 times F, is, okay, as soon as you see is always going to be equals. So 4F equals 30 less than 5 times his age. Okay, so 5F and 30 less than that. And we got it, okay? Setup's all I want here. Right, we don't have to do anything with the solution. We're just setting up the equations on these. So like, let's say we're doing, let's go back to 13 for a second. Anna deposited $76 in her checking account. This tripled the amount she had in her account. How much did she have before? Okay, now this is a little trickier. Well, let's think about this for a second. Okay, if she had money before, okay, she started with X dollars, okay? So she's going to deposit money. When you deposit money, what are you doing? You're putting it in. So we're going to add triple the amount she had in her account. So 3x. And once I add that, I'm going to have my 76. That one's a little trickier. Because you don't think about she had money there already and then she added the amount to triple it. We just think about, oh, a triple would just be 3. So I'm glad we kind of talked about it. Yeah, we're just doing the equation. We're not solving. Let's drop down to 16 here. Alvin rented a car from Speedy Car Rental. They charged $30 plus 20 cents a mile. Okay. X is going to be my miles. So, I get charged $30 if I drive 1 mile, 100, doesn't matter. I'm going to get charged that $30 anyway. Right. The per mile stuff. Anything you see per mile, per hour, per whatever, that's the one that's going to get an X with it. So $30 plus 0.20x, because it does matter how many miles I drive, is going to equal the other part. Well, the other guys charge $20.30 a mile. How would I write this part for the other side of my equation? Okay, so what would that look like? 20 plus 0.30x. Wherever that per part is, that's the part that gets my variable, my x. And then again, I could solve this, but I just wanted to practice getting some of these set up. I'm only going to have you do a couple. And I'm going to do 18 with you, and then I'm going to leave 15 and 17. So last one. Anna ordered some bathing suits from a mail order catalog for $32.50 each. She had to pay a delivery charge of $7.25. She could make the same number of bathing suits for $17.50 each and save $52.25 instead of ordering the catalog suits. How many bathing suits did she purchase? Let's start at the beginning. You're like, dang, that's a whole lot of stuff. So she's paying $32.50 each, but she had to, we're going to keep with the basic equations when we're doing this. I just want to get you some experience with it. Well, yeah, we'll end up getting there later down the road. So, delivery charge, $7.25 no matter how many suits she orders. So it's sort of like our $30 up here above. But the number of bathing suits, that changes. We don't know how many she ordered. That's what we're trying to figure out. We also know that she could make the same number of bathing suits for $17.50 each and save $52.25. So the question is, which one of these gets the X? Okay. Right. In this case, 1750x, and we'd minus it because we're saving it. We're not having to spend that. And again, it's just kind of giving you some experience, seeing, because sometimes some of you think, okay, when am I ever going to be worrying about, what negative 9x plus 5 equals negative 6x? When do I ever care about that? This is the point where these things start to come in. You're comparing two things to see what the better deal is, okay? Or how much it costs to break even. We've done some break-even problems that would be the same. It's the same type of idea, but I just want to introduce you to them a little bit. So your job is to do the equations on this side, and then the back is getting you some practice. Now again, I'll mention this. The ones at the bottom on the back that say C1 and C2, those are extra credit because now there's fractions involved. We're going to get to fractions, but if some of you think you might want to give these a shot and think you can do this, I say go for it. But otherwise, it's just a review of what we've been doing. Okay? So take a bit of the time you got here. We got about 20 minutes. Work through some of these. it's going good, great. If it's not, talk to me. Let's get you set on some stuff and see how this is going.